Okay, so in the world, cycles govern many aspects of life. Heartbeat, sleep patterns, seasons, and tides all follow regular, predictable cycles. In this section, we're going to talk about why trigonometric functions are used to model those cycles, because trigonometric functions are also cyclical. We are moving beyond angles, and we are talking about trigonometric functions of just all real numbers. By 5.5 is when we'll start doing like the sine curve graphs. So this is us moving off of a circle. So we went from triangles to a circle that goes around forever to a curve. Okay. We got to get through this and that. Circles that go on forever and curves. And then we're going back to triangles. And then that's probably as far as we'll get this semester. Okay. Thus far, we've considered trigonometric functions of all angles, measured in degrees and radians. To determine trigonometric functions of real numbers rather than angles, we are going to use a unit circle. A unit circle, I would put a star here, is a circle of radius 1 with its center at the origin of a rectangular coordinate system. The equation of a unit circle is x squared plus y squared equals 1. So that's just the equation of a circle with a radius of 1. Yes. This is a picture of a unit circle. Center at 0, 0, radius of 1. Because we know that this angle is t radians, we know, and I know that's super tiny because it's a really bad snip and clip, t radians, we can use the formula to find the length of a circular arc, which is that the s, which is the length of a circular arc, equals r times theta. Well, r is 1 and theta is t, so s just equals t. So that means that the measure of a central angle in radians is the same as the length of the intercepted arc, which I have some spooky animations to show you, maybe today, maybe tomorrow. So basically, now that we have that, we, instead of having our trig functions be of angles, now our radians and our anglings, it's the whole thing. You can read through that next paragraph if you want. I'm not going to read it out loud because we don't need that yet. So down here, using this figure, we can define the cosine function of r as the x coordinate. So cosine is still x. And the reason why is because it's x over r. My r is always 1 now. So cosine of theta is x over r. But since r always equals 1, therefore cosine of theta is just x. Sine of theta, we used to be able to define as y over r. I'm still are able to define it as y over r. But now that we know r is always going to be 1, sine of theta is just y. So that's what we're using today, is basically the exact same functions we've had, but now r is always 1. So they've got one example down here already done for you. We can find cosine and sine. For an example, I can't read, it's too small. Point P, x1, use a real number. Oh, so the coordinate of the coordinate down here is -3/5, -4/5. Because the cosine function of the x coordinate and the p coordinate, the values of those trigonometric functions. So the x coordinate, -3/5, the y coordinate, -4/5. Instead of having to solve anything, your sine will always be y, your cosine will always be x now. So it actually ends up being less work. It's also another one of those things where I can't explain it to you until you understand it, and you can't understand it until I explain it to you. So you kind of got to go back and forth a little bit as we go. So don't stress out about it. Here are the formulas. Here's what you actually need to be able to apply. So on the next page, which was supposed to be the back, sine of t is always equal to y. Cosine of t is always equal to x. This has to be a unit circle with a radius of 1, though. Tangent is still y over x. And then our other three functions are still just flipping them. So for y, we'll flip, or for cosecant, we'll flip sine. For secant, we'll flip cosine. For cotangent, we'll flip tangent. So with that being said, let's do this first example. In the figure 5.56, which is that t is a real number equal to the length of the intercepted arc of an angle that measures t radians, this is my point. So my x is negative 1/2. My y is square root of 3 over 2. We just need to find our trig functions. So we're doing sine, cosine, tangent, cotangent, secant, cosecant. Our sine function is always y. So sine of t is just square root of 3 over 2. It's just our y coordinate. Our cosine function is just our x coordinate. So it's just negative 1/2. So sine is just y, cosine is just x. Tangent, we'll have to actually do some math. Tangent is y over x. I'm going to put parentheses here because I can't write in italics like they can. Tangent is y over x. So that's going to be square root of 3 over 2 divided by, because that's what over means, negative 1/2. So I'm doing square root of 3 over 2 divided by negative 1/2. I'm going to keep my first one. I'm going to flip my second fraction and change it to multiplication. So these cancel. Tangent is negative square root of 3. Okay, questions right now. I bet you have no idea why, but all you need to know right now, and we'll start figuring it out piece by piece. All you need to understand right now is that your sine is your y coordinate. So sine is literally just y, cosine is literally just x. And then tangent is y over x. I freaked out and thought I did x over y. It's y over x. Okay, then let's do our reciprocals. So cosecant of t is going to be 2 over square root of 3. So we'll have to rationalize that denominator. Except maybe not in Math Excel, turns out. So I multiplied by rad 3 over 3. Gave me 2 rad 3 over 3. Cosine of t is the reciprocal of secant of t. So for that one, we can flip it. It's just 2 over negative 1. And that's just going to be negative 2. And then the last one, tangent, is the reciprocal of cotangent. So I'm going to take, I'm trying to figure out the easiest way to do this. So cotangent of t, I'll do 1 over negative rad 3. I'm going to put the negative on top, actually, and then I'll rationalize that, sorry. Square root of 3 over square root of 3. So that's negative rad 3 over positive 3. Okay, so sine and cosine are just y at x, tangent's y over x, and then flip them all, rationalize your denominators if MathXL makes you. That's about it. Any questions on any of those? So what we've done in trigonometry so far is gone from SOHCAHTOA to y's and x's and r's to just y's and x's. Because we've gone from triangles, any triangle, or any right triangle, to any circle, to circles only with a radius of 1. And we'll just keep going, and eventually it's getting like more complicated, but simpler at the same time. Because there's only one value here. Sine of t is just y, cosine of t is just x. Okay. Last thing that we're going to do today is this problem down here. It says use figure 5.57 to find the values of the trigonometric function at t equals pi over 2. And so in your text, or well, not in your textbook, it's in my textbook. It'll be on MathXL for you. There's a whole chunk of problems that it's going to say use this graph. And so you just have to figure out that this is 0, 30, 60, 90. And so you use that graph to evaluate trigonometric functions at certain values. Okay, sorry, I was looking at something. All right, so for this first one, or for this one, we'll do sine and cosine first. So sine of t. My point is just 0, 1. So x equals 0, y equals 1. How much did you spill?
Not much. I'm cleaning up with it now.
Come back. Let me finish notes, and then let me use real absorbent paper towels and a Clorox wipe instead of you trying to just... If you rub that Big K brand red cream soda around with a school paper towel, nothing's going to happen.
Okay.
We'll clean it up in a second, okay?
All right.
Because that's like bad sugar soda with a bad quality paper towel. Just move to another desk.
That's like slowly dripping towards me.
Here, grab paper towels out of there. They're in here. Yeah. I think they're on the left there. See them? Yes. Please use real paper towels. Wait, are there paper towels in there?
No. I don't see any. There's napkins.
Open this cabinet down here. Are there paper towels in there?
Yeah.
Okay. Use real paper towels and then a Clorox wipe. Okay. Sine of t is just my y value, so sine of t is just 1. Cosine of t is just my x value, so cosine is just 0. Tangent of t is y over x. So y over x is going to be 1 over 0. Can I do that? So it's undefined. Okay. Then we'll do our reciprocals. Reciprocal of sine is cosecant. Cosecant of t, we would take 1. To make it a fraction, we would make it 1 over 1. 1 over 1 flipped is still going to be 1. To flip cosine, it would be secant. This is currently, we can think about it as 0 over 1 equals 0. So to flip this, it would be 1 over 0. So it's going to be undefined again. And then cotangent, we get to flip this. So instead of 1 over 0, it's 0 over 1. So then it is actually just 0. Okay. Your assignment today, don't overthink it. Your x value in your coordinate pair is always cosine. Your y value in your coordinate pair is always sine. And then tangent is just y over x. Let me log into MathXL. Let me stop this video. Bye, video. Miss you. Let me log into MathXL and look at something.